How do forces affect us? That's where we're going to take a look in this lesson, which is chapter 16, lesson 1. And that means we finished chapters 12, 13, 14, 15, and now we're on the last one, chapter 16. And in addition to this lesson, we're also going to take a look at, if I can get my marker here, how do forces interact and what is gravitational force? More on that to come. The first term to be aware of is frame of reference. And a frame of reference is a point of view that can change depending on the position of the viewer. So for example, you can see that there is a person standing on this moving train. The train is probably moving this way. And the person says, "Hey, I am standing still." But the person on the ground is saying, "Wait, hold still." How can it be that the one person thinks she isn't moving and the other thinks that she is? Well, it all depends on the vantage point of the observer. And by that I mean the person that is on the train riding, like you in the backseat of a car, is seeing one thing, and the person that's on the ground looking at that person is seeing something completely different. And they're both seeing something legitimate. It's just that they have a different point of view. They have a different frame of reference. And you probably can make the connection to reading and language arts with point of view, first person, second person, and third person. It's just a different perspective from which you're looking at the same story. Likewise, this is a different perspective from which a person is observing something in motion. A great way to understand this concept is to watch this video. So I'd like you just to pause right now, take a moment to pause the video. See if I can type, and watch the one here in front of you. And when it's done, then you can come back to the video you're watching right now.
Good morning.
Think about it. Oops, if I can go on to the next one. Think about it. How do you know that another object is moving? Well, based on the video that you just watched there, hopefully you can also conclude, let me get the right color here. You can conclude that you would observe the object that is moving and compare it to other objects that are not moving. You can also compare it to yourself. So you could look, for instance, if you saw somebody walking and you were standing on a sidewalk across the street, you could watch that person walking down the sidewalk and compare them to where they were in respect to buildings or trees or stop signs, whatever is out there. And you could also compare them to where you yourself are standing. So that's one thing you could consider. If I can make this bigger again, let me try. There we go. All right. Another consideration is, how can you tell whether another object is moving if you are also moving? Well, same thing. You're going to observe the object that is moving and compare it to other objects that are not moving. Now, you can't compare it to yourself this time because you are also moving, but you can definitely compare it to objects that are not moving. So take a minute to write that down if you haven't. Velocity is our next term, and velocity simply means the speed and direction of a moving object. For instance, if you take a look at this car over here, you can see that it has a speed of 20 meters per second. And we typically write or talk about miles per hour of cars, but in science we measure 20 meters per second. Or I should say not necessarily 20, but just meters per second. That's common. That's speed. But if you want to know velocity, it's 20 meters per second that the car is traveling. And then they add a direction, east. That's a big deal. That direction with it changes everything. So now we know what direction it's going. If a ball were falling, you could say 9.8 meters per second squared down, since it's going a direction downward like this. Oops, let me get an arrow. It's going down. That would be a direction. You could talk about a bird flying up at a certain speed. But the key here is that it has a speed. If I can get my arrow again, it's got a speed and it also has a direction. So a great way to understand this concept again is to watch this video. So go ahead and pause this video and watch the one in front of you here. And then when you're done, come back and watch the video that you're watching right now. Take a minute and think about it. What does the above number, the one that's right here, 50 meters per second, what does that measure? Is it speed? Is it velocity? Is it how far a car can drive? The correct response is speed. It's measuring speed because it's just got a distance over time. What would you have to do to convert the speed to a velocity? You would need to add a direction. So here's an example of that. You could say 50 meters per second west or northwest or whatever. But for it to work, you need to add a direction. There we go. Okay. Term number 3 is force. And force is simply a push or a pull. So if you're sitting at a desk and you pick up a book, you are probably pulling the book initially and then pushing it up into the air. You might push a door open or pull the door. You might stand up, you're pushing off the ground. You might sit down, you're still pushing on the ground to slowly let yourself down. So every force is a push or a pull. So let's look at some examples. I encourage you to take a minute and watch 2 videos. This one here, watch that and look for examples and see if you can identify whether it's a push or pull with the video. And then watch this and notice the difference between contact and non-contact forces as well. And then having watched both those videos, come back and continue watching this video, but make sure you watch this one and then answer this question. Think about it. Give 2 examples of pulls and 2 examples of pushes, which should be fairly simple, but try to pull some that are new, maybe that you got from the video. All right, acceleration is our last term that we're going to discuss today. And acceleration is an object's change in velocity divided by the time it takes for the change to occur. So simply put, it's a complicated definition, but it doesn't need to be. If you would think about velocity, remember it's got 2 elements. It's got speed and direction. Now, if you want to change something's velocity, you can do it 3 ways. You could change the speed. You could have something just go faster. It's just speeding up. So maybe it's going from, like up here, it's going from one point to another and going faster and faster. A good illustration of this is if you think of a car at a stoplight. When the light turns green, the car is going to start picking up speed, and the speed is going to increase. That's a velocity change. Now, you could also take a person who's running or jogging, and that person could be going the same speed the whole time, but they could turn left, or they could go right, or they could go north or west, changing their direction. The speed stays the same, but the direction changes. That is also a change in velocity. So you only need one or the other to change. A car that is going the same speed but just turns or goes around a bend is changing velocity. You can change both of them. A person could speed up and go right, or a car could slow down and turn left or go west, whatever. But you need at least one change in speed or direction to have a change in velocity. So you consider that change, that's the first part in velocity, and then you divide it by how much time it takes for this to happen. And that is something that we're going to explore in greater detail tomorrow when we pick up this video.